Let's find how to find the center of gravity of a solid cone. So the main thing about this is there is mass distributed even in the interior section. So that is the main difference between a solid cone and a hollow cone. So if we just look at these, if I'm able to arrange certain coins with a certain thickness but with different radius, I'm able to get a cone in this case. So that is a basic idea you should get. What is the geometry you must consider? So if you look at here, by arranging certain cylindrical coins with different radius. So the y value around here and the y value around here is different. So the y value is changing and that is the radius. So y is the radius of the cylinder and with negligible thickness dx. Now the slanted nature is negligible because when compared to the mass of the interior sections, the negligible mass covered by this slanted part is ignored. So we can just consider this cylindrical section as dx, so the cylindrical height, and the radius is y. So when you know the geometry, you can just go around pi y squared dx, because the entire mass of them is considered. The volume, when it multiplied by the density, I'm going to obtain the negligible mass of it as dm. And you can see that, let's say if the cylinder is at a distance x, of course the location of the center of gravity will be at x again. So these are things you should note down here. So, and you can see that this is in dx, but you are having a y variable. So it is unable to integrate. So let's try to get an answer for y in terms of x. So for that, if you nicely observe, you are having y and x and the half angle around here. So we can say that tan alpha is equal to y over x. And mostly they won't give you this half angle. So it's better to relate with someone else. So you can almost find the tan angle from here as well. If the radius of the cone is r, if the height of the cone is h, then you will find it as r divided by h. So now we know an answer for the y in terms of some constant and an x variable. So now we know the value of y. So now we can just find the center of gravity. It is actually the mass into the distance, so you get the moment divided by the total mass. So pi y squared rho times of dx, that's the mass. When you multiply the location, it is at x, divided by the negligible mass is pi y squared rho times of dx. And you can see that the x value is changing from 0 to h. So the limit of the integration is 0 to h. 0 to h. And now you know an answer for y, which is r over h x. So the center of gravity would be, I think it is 3/4 of h. So just simplify it. But the basic procedure behind that is this. You must consider a tiny cylinder of variable radius and a given thickness.